Okay, welcome back. This is the third lecture of Unit 6. So, we will discuss about exercise 6.1. Okay, the first question is all circles are whether it is concurrent or similar. So, if it has to be concurrent, so the circles, let us draw two circles. So, the first circle is like this, the second circle can be like this, the third circle can be something like this. So, all these circles, the radius of all the three circles are varying. Okay, so the shape looks okay, but the length are not okay. So it is similar. The radius are not equal. So it is similar, but it is not concurrent. Concurrent means the radius has to be same. So all circles are similar and not concurrent. Please note down, for circles we don't have any angle or any side. We have only one thing, that is the radius. Okay, for a complete circle we have only radius. So all circle are similar. Circles with equal radii are both similar and concurrent. Okay, all circle are similar. Circles, please note down, circles with same radii are whether it is concurrent or similar. It is both concurrent and similar. It is both concurrent and also similar. It is both concurrent and similar. Okay, fine. So coming to the second one, all squares are whether it is similar or concurrent. It is similar. All squares are going to be similar because the angles are going to be equal 90-degree for the squares, whereas for the sides can vary proportionally. Okay, so all squares are similar, but it is not concurrent. Coming to the third one, all dashed triangles are similar. So which triangle is going to be similar? Whether is it going to be isosceles triangle or equilateral triangle? First of all, let us understand what is called as isosceles triangle. I think already in your early in your ninth standard you would have studied about this isosceles triangle. Okay, so let us take two triangles. So I'm just drawing two triangles, and let us try to mark some angles. So this can be say an isosceles triangle, say an angle alpha, and this can also will have an angle of alpha and alpha. So if this triangle is also having an angle alpha, then these two triangles are similar. These two triangles, these two isosceles triangle can be called as similar. But it need not to be alpha, right? This can be beta also. This angle can be beta and this also can be beta. These two angles are alpha and alpha. These two angles can be beta and beta. So this is also an isosceles triangle. This is also an isosceles triangle. Whether these two isosceles triangle are similar? No, it is not similar. Why? Means the angles are varying. It is not equal. The angles are not equal. Here we have angle alpha and here we have angle as beta. So it is not same. So this cannot be accepted as a similar triangle. So whether all the isosceles triangles are similar? No, it is not so. Okay. So because it can have angle alpha, here it can be beta also. So not here there is a term all. We have to look carefully. Whether all the isosceles triangle? No. See, in this condition, this is also an isosceles triangle, this is also an isosceles triangle. But these two triangles are not similar because the angle are not same. Okay. So, but whereas if you take the equilateral triangle, all the angles will be 90-degree. All three angles will be 90-degree. So obviously it has to be similar. Okay. So all equilateral triangles are similar. Not all isosceles triangle are not similar. Yeah, all isosceles triangle are not similar, whereas all equilateral triangles are similar. So that is the answer. Okay, coming to the next one. Two polygons of the same number of sides are similar if their corresponding angles are. So when we talk about the angles, it has to be equal. It should not be proportional. So the corresponding angles are equal, and their corresponding sides are proportional. Okay, angles has to be equal. The sides has to be proportional. If angles are proportional, what will happen? The figure will be in some other shape. Okay, so angles cannot be proportional, should not be proportional. It has to be equal, and whereas the sides can be proportional. Okay, so coming to the next one, give two different examples of pair, similar figures and non-similar figures. We need to give some examples. Okay, for example, for similar figure, we can draw, say, a rectangle. We'll try to draw a rectangle. So this is one rectangle, and I am going to draw one more small rectangle like this. Okay, so in rectangle we know the angles are 90 degrees, so no need to mention the angles, but we can mention the lines. So mention the we can mention the sides. So let this be L, so this can be, say, 2L, and let this be B, so this has to be 2B. So this is an example for similar figure. So non-similar figure, say for non-similar figure, what I will do, I can draw a square and I can draw a circle. These two are not similar. Or I can draw two isosceles triangles. I can draw an isosceles triangle. Say this is, say, 50 degrees. This is also 50 degrees. And one more isosceles triangle with an angle of, say, 55 degrees. Here also 55 degrees. So these two triangles are not similar. Okay, fine. Coming to the third problem. State whether the following equilaterals are similar or not. Whether it is similar? No, it is not similar because the angles are not same. This seems to be like a square, so here it is 90 degrees, all the angle are 90-degree, whereas here there is an acute angle, here there is an obtuse angle here, so the angles are not similar. Even though the sides are proportional, okay, we can observe it is 1.5, 1.5, 1.5, 1.5, here it is 3, 3, 3 and 3, so it is proportional, but still the angles are not similar, so it is not, it is not similar. Okay, thank you.